So Ramesh, you showed me what UART looks on the line, and then you showed me inside how it works inside the chip. But can you explain the software to me, please?
So remember the software, whenever we think of a software driver, most of our drivers have two parts to them. There's a setup, which we do once, and the repeated use of it.
Yeah, like inputting and outputting.
We already saw the input and output. We check a flag and then we read or we write.
Yeah, but the setup's kind of complicated.
The setup is complicated, but every step is is self-explanatory as to what it does. So let's go through it and see how the setup really works. So here's the code for it, and we'll just go through each line.
All right.
Like with any driver, any device, this is our UART device, and so there must be some device-specific registers that we have to look at, right? Okay. And those registers come in play here. So here are our device registers for this one. So there's not a whole lot, but we'll see what exactly they do. So let's walk through our code. So this is our initialization. These steps have to do with the port itself, because we're working with UART, and like all devices, we have to enable them, do the reset control and power enable. This is something we did for all GPIO, so this is no different. We wait for some time to activate, because every initialization needs this delay, so we wait for it to activate. Now is the UART specific stuff.
Now the interesting stuff.
Okay. So let's take a look at our first thing. We've been using the pin configuration management to set up whether something is an input or output. One of those bits in there was the mode bit. These last bits here, these are called bits 5 through 0, are the mode bit. When we were doing GPIO, we made this mode bit be a 1. Now in this case we're gonna make it a 2, and so we'll see where this 2 comes from. So we'll do that both for the input and output. In this particular example that I have here, we are connecting a UART, and where the transmission pin, which is the output pin, happens to be on, our output pin happens to be on PA10. We're writing on PA10, and our input pin is on PA, let's look at that,
11.
PA11, right? And so input is PA11, so we're going to do input configuration for that, and PA10 is output, so we'll do output configuration.
But you got a 2. So what are the other bits in that register? Why is there an 8 there?
So remember that the other bit, this 8, has to do with our PC, that is program control.
Or peripheral connected.
Peripheral connected, yes.
Got it.
So the PC bit is still there. That's still there for both of them. And for the input, we have to do an input enable, which is this bit 18. So that's what this guy is.
All right.
So the only thing new here is the mode bit. The mode bit is something that we set based on what mode we want to use this pin. This pin is no longer a GPIO. We want to engage a protocol on it. Specifically, we want to engage the UART protocol on it. So we're gonna have to look at where this comes from. Now, to do that, I'm just gonna come back to this picture, but this is a table that gives us that detail.
Ooh.
So it's a table that explains all the modes. Remember that PIN-CM bits 5 through PIN-CM 5 through 0. Whatever number we put here is the mode.
Oh, I see.
So we've been doing mode all this time, which was mode. This is the mode we were doing, mode 1.
For
and
GPIO.
if you notice, they're basically all the pins and they tell us what to do. But now we want to use UART. And which are our 2 pins? We said PA10 and 11. And we'll go down here, we'll see PA10 and 11. Those are our 2 pins.
Okay.
Right? And we want the mode on them, we want to be this mode. That is we want the 10 to be a transmitter and 11 to be a receiver.
And so U0 means UART 0.
Exactly.
And then where's the 2 here in
And
this?
so the 2 is
Oh,
the
oh, yeah, I
column.
see it. I
This
see it.
column
Oh, I see it.
number
Yeah.
is column number, and that 2 is what that becomes our mode. So by selecting mode 2, to select mode 2, we write the number 10 into this 5 bits.
Got it.
2 or 10 into those 5 bits. So we go back, we can see now that that's where the 2 came from.
Got
It's
it.
the column number in that table that we chose.
Got it.
And now we're moving on. We did all our configuration. Now we'll do some UART specific one. Now this is where our registers come into play. One of the first things that we're doing is we're choosing what is our, remember that baud rate calculation we do, we're asking what is it based on? What is the basis for it? We're going to use a bus clock for it. So this clock select register has a bit here that tells us what we are using, which is the bus clock.
Oh, I see it right there, bit
And
3.
so bit 3, and so writing a 1 in the bit 3 is like writing 8 in there, and that bit is a 1 to select the bus
So
clock.
it brings the baud rate clock from the processor clock,
Exactly.
the 80 megahertz bus clock.
Bus clock.
Is the origin of the way in which it determines the baud rate.
Yes.
Got it.
And now the next one is you can actually choose that if that is of a resolution that's not immediate value, you can use a divider. And the divider is where this clock division is. We're not going to use that, so we just set this ratio. This is how we divide it, and we just put a 0 here.
And that means divide by 1.
And that's divide by 1. That is
Because
divide by,
John doesn't want to go slow. I want to
Yeah.
go fast.
yes, divide by 1 is 2 to the power of 0, so that's all that is.
Yeah,
Now,
got it.
Now we have our actual setup, and remember, anytime we are working with any device, while we're messing around with its configuration, we wrap it in an enable and disable.
The other way around. Ramesh.
So disable and enable, yeah. So that the UART doesn't start running immediately after you start doing things to it. So that enable and disable bit is a bit right here in the control register, and that is this bit.
Got it. I see it. Bit
And
0.
we started off with setting it to a 1, which is actually setting it to a 0 by doing AND with a complement, and we'll eventually turn it on by making a 1.
Okay.
So that's our thing. But internally, there are a few steps we're performing. The few steps we're performing internally,
Because you remember in the last video, you showed me those 4
Yeah, exactly.
deep FIFOs.
Yes. So we're gonna enable the FIFO, which is, there's a bit here called FIFO enable, which is bit 17.
Got it.
That's a FIFO enable. So we turn that bit on, and that's where this 2 is coming from, right? And then we have we're gonna make sure that both we're using transmit and receive. So transmit and receive. So this is my receive bit, which is this guy, this 8 is my receive, and then I have my transmit, which is this guy here.
So I turn on the transmitter and the receiver and the FIFOs.
And the FIFO.
Yeah,
So
we love FIFOs.
And I'm ready to go. So now these 2 steps here are setting the baud rate. We're setting the baud rate, because remember that clock we talked about, which
And remind me what baud rate is again.
the baud rate is when I'm transmitting on the line, I want the shift register to shift 1 bit at a time onto the line, and that bit duration is whatever that delta t is. 1 over that delta t is the rate at which I'll transmit. That's my baud rate.
Okay.
And I want to tell exactly what that is, and we'll do the math for it. And in this example, I'm using a baud rate of 115,200, which is a standard baud rate
In bits per second.
In bits per second. So I want to set these values. The baud rate is derived, has 2 parts to it. There's an integer part to it and a fractional part to it, right?
Yep.
So we're gonna set that accordingly, and the computation is given to us here, and the idea is pretty straightforward. That is, we take our bus clock, which in our case was 80 megahertz, and it turns out that in the UART only uses works based on half of that, which is 40 times 10 to the power of 6 divided by 16 times whatever your baud rate. You compute this number. It has an integer part and a fraction part.
Got it.
And we take the integer part and we write it to the IBRD register. Simple enough. We take the fraction part, and this is represented as a fixed point number with a resolution of, it's a binary fixed point number with a resolution of 1 over 64 or 2 to the power of minus 6. So what does it mean? So I take this number and I multiply that by 64 and I round it.
Got it.
I round it and I write that to my FBRD register. And that's exactly what we're doing. We're taking this number 40 times 10 to the power of 6, 16 times 115 to 100. So we did the division. We got a 7.01. 21 goes here. We take the 0.701, multiply that by 64.
Yep.
And round it, and we get a 45.
Okay, so that's because what you told me last time is the transmitter and receiver have to run at the same rate.
The same rate.
And so this is a very accurate way for each module to set its baud rate so the two baud rates are
equal, right? So now the last bit of homekeeping we have to do is we have to decide what are we transmitting. And what we are transmitting is 8 bits of data, and it turns out we can transmit more than 8 bits if we have a parity, but we only transmit 8 bits, that's a byte. We want a stop bit, and we want no parity.
All right.
So those are all in this LCRH. All right, so we have 0, 0, 0, 3, 0. So I have 0, 0, 0, 0. That's the first nibble, if you will. That's a 1, 1 here. And then that's 5 and 4. And then I have a 0 and a 0.
Got it.
Because that's a 3.
All right.
And so what we have then is our what tells us here is what the length is, what the stop bit is. There's no parity, which is this one. Parity enable is that one.
And no break.
And no break. We're not touching all the other bits. No break.
Okay.
And our length is 8 bits, and our stop bit. We want a stop bit.
And there's always a start bit, so we don't have to say, give me a start bit.
Start bit.
I got it.
So that's in essence what we're doing.